Find the area of the region enclosed by the graph of the equation x squared plus y squared equal to absolute value x plus absolute value y. So what we're going to do is we are going to break this one into 4 different cases. Case 1, x greater than 0, y greater than 0, that's in quadrant 1, quadrant 2, quadrant 3 and quadrant 4. So those are case 2, case 3, case 4. First what we do, we solve this problem, basically trying to sketch the graph of this equation in the first quadrant. So this equation become, in the first quadrant, x greater than 0, y greater than 0, so absolute value x is going to be x, absolute value y is going to be y. So x squared plus y squared equal x plus y. Then what you do is, transform this equation into a equation of a circle in the form x minus h whole quadrant square, y minus k whole quadrant square equal r square. So here h and k are the center of the circle, h comma k, and r is the radius. So what we do is we come back to the problem. So we have what, x squared minus x plus y squared minus y. Then you do the completing square technique. So we end up in getting x minus 1/2 whole quadrant squared plus y minus 1/2 whole quadrant squared equal to, so here you added 1/2 whole quadrant squared and here you added another 1/2. So that means twice 1/2 whole squared goes to the right side to make the equation equal or balanced. So what are you going to have is, now you have the center is 1/2 1/2 and the radius is going to be square root of this number, that's r. So that's going to be square root of 2, that's going to be square root of 2 divided by 1/2 whole quadrant square root, that's going to be 2. So that's square root of 2 over 2. So now we go back to that equation now. So you can sketch this portion of this one first. So what you have is, you have this center 1/2 1/2 and it has a it intersects x-axis at 1 0, y-axis at 0 1. So the radius is going to be square root over 2 over 2. So what you have is it intersect here, goes like that. So then you go to the second quadrant, you will get a graph like that. And what is going to happen in the second quadrant, here x is less than 0, so this becomes negative x and this is going to still y. So you do the same thing, like we did over here. You get negative 1/2 1/2. So you get this circle or semicircle, then again you get this semicircle in the third quadrant and you get this one in the fourth quadrant. So that's what we call using the symmetric property. So you don't have to sketch the graph in every quadrant, just do it in one quadrant, use the same idea to sketch the graph of this one in the other quadrant. So what you have is, you have 4 semicircle and in the middle you have a square, and you see that, or maybe if you look at this right angle triangle, it has base is going to be 1, height is going to be 1. So what do you do is, so to find the area of this 4 semicircle equivalent to, because they all have same radius, equivalent to 2 complete circle. So to find the area of a circle, you use the formula pi r squared. So pi times square root of 2 over 2 whole quadrant squared, and you multiply by 2 because we have 2 complete circle. That means 2 pi times 2 over 4, that's going to be pi. So that's what you get from adding area of this semicircle. But we have something in the middle, that is this square. So to find the square, the easiest way is go and find the area of this right angle triangle. They're all going to be same. All you do is find the area of this one, 1/2 times 1, that's going to be 1/2. So you got 4 of those, 1/2 times 4, that's going to be 2. So what do you have is, here's the area of the square, that's 2, and area of the total area of all the 4 semicircle is pi, so the answer is pi plus 2.